Hello. In this topic, we are going to see the main features of HANA in more detail. Let's start with the RAM. We all know the RAM is much faster, even with our experience with personal computers. I remember when I was a kid, we always wanted more RAM to run our games much faster. So it's a very similar concept in enterprise software as well. You see, RAM was much expensive like 10 years, maybe even 20 years ago, but as the time progressed and technology progressed, the cost of RAM came much lower. Today, RAM is affordable for enterprise software. So the guys in SAP thought, why don't we build a brand new database which works just out of RAM? That's how HANA was created by SAP. Now coming back to HANA, if you take a look at this diagram, we have two different data stores inside the RAM, one called the column store and another one called the row store. So both of these reside inside the RAM. If you create a table of a row type or if you create a table of a column type, both of them still are living inside the RAM. And so same goes with all the engines, and they all stay within the RAM. So for example, we have the OLAP engine, we have the join engine, we have the text analysis engine. So we have so many other engines which we will see in a later topic. But for now, let's try to understand that all of these are inside the RAM. The performance time of the RAM in terms of the scan speed is about 2 megabytes per millisecond per core. 1 GB roughly in 0.5 seconds per core. If you have to scan through 100 GB, that would take 50 seconds per core. So if you had 50 cores, that will take per second. That's the kind of a match behind the read times of RAM and why it's fast if you use RAM instead of a hard drive. Let's talk about compression. Compression is an important factor in HANA, and it's also used internally in the column store. Compression is the phenomenon where we use certain set of algorithms to reduce the data footprint. In this example, we have this table of materials and names and quantities. So this is a subset of a transaction table you can find in any store, like for example, Fry's or Walmart. Now what we have to observe is that the material is repeated. For example, if you see radio is repeated here and then here. Similarly, the customer names are repeated as well. For example, Dubios is repeated here and then it's repeated here. Same goes with Miller, repeated here and then repeated here. And obviously the quantity will be repeated over a period of time. So the idea is very simple, that let's remove the repetition, build a vector for that and use only an integer to point to that vector. So that's what is done here. A vector is built for customers and a vector is built for the material column. These are all string types. So string is much more expensive to store than an actual integer. Is done is this table, the compressed table, is superimposed with the vector numbers. For example, material here, it says 2 instead of radio. So if you go to the vector, it's very easy to find out 2 is equal to radio. So the good thing is the processing of the query and the data is done in the compressed format. Therefore, it's much easier for the engines to function and it's much faster. Let's take an example of compression. Let's take all the names in the world. Roughly there are about 5 million first names throughout the world. So if you take that item size, we need about 50 bytes per item, and if you total it, it comes up to somewhere around 373 GB. Now if you compress it, the dictionary will take about 240 MB and the actual vector will take about 22 GB. So we are roughly talking about less than 25 GB. So we can achieve a compression ratio of 17. Now to translate this 17 compression ratio in real world, first thing to keep in mind is that compression ratio is directly proportional to the cardinality of your database, or in other words, it's called as entropy. That is basically the cardinality of your column to the cardinality of the table. So let's say that you have 100 GB of data in your database. When you migrate to HANA, your data footprint will be less than 6 GB. Isn't that amazing? Just two more concepts and we are done with this video. Let's take a look at column store. First, we will take a look at the table and then how it is stored in a row fashion, and then we'll take a look at how it is stored in a column fashion. So this table has 3 columns, A, B, and C, and then it has one header, and then row 1, row 2, row 3, and then row 4. If you were to store this in a row fashion, you would take the first row, that is 1, 1, 1, and store it sequentially in the memory. because that's the only way you can store in memory. And then you take the second row and then store it sequentially, and then so on. Now, if you take the column store, you take the column and then store it sequentially. You store 1, 2, 1, 2, that is 1, 2, 1, 2, and then you go to the next column, column B, which is 1, 2, 3, 4. So you see 1, 2, 3, 4, and so on. So that is the basic fundamental difference between how you store in a row storage and in a column storage. Now, why we should do this? Because column storage supports really fast in-memory processing of operations such as aggregates, which generally are very expensive. It supports sequential memory access. It also supports massive parallel processing. Searching on a column store is much faster than searching on a row store, provided you are only selecting a set of columns. When you convert this to an actual example in a SAP ERP system, we can take example of the BSEC table, which is a very important table, accounting table in the SAP ERP. It has more than 200 columns. Now, most of the time, you don't use more than 10 to 20 columns. So, therefore, converting a table like BSEC to a column store will make it much faster to process and to run queries on top of BSEC. A little bit more about column store. Now, there is some understanding in the industry today that column store is for reading purpose and row store is for writing. This is not true in the case of HANA, because they have built the column store in such a way that it does both read and write efficiently. How they do it is they have split the storage in three parts. One is the main part, and then we have delta, and then we have L1 cache. All the persisted data sits in the main memory, and all the buffer, all the changes are captured in delta, and L1 is created to capture very high inserts like event processing and other things like Internet of Things. So everything put together, column store plays a very important role in the whole SAP HANA solution. In the next topic, we will talk about SAP HANA solution proof points.